Greetings to everybody. Today our project is Hand Gesture Volume Control System. This project helps us to control our system from our comfort zone without the use of any mouse or touchpad. Now we come to the main part of our code description. The code description is divided into two parts: the module description and the code itself. The module description has all the modules which we are using in the code. CV2 media pipe, which is defined as MP, matplotlib.pyplot, which is defined as PLT, ipython.display, of which we are using only two parts, that is display and clear output, pycow, which we are taking also two parts, audio utilities and iAudio endpoint volume, and C type for the pointer distribution and com type for the class distribution. Now we come down to the main part of our code: volume control. First of all, we initialize the volume so that any previous data which was captured does not hinder our new code. Then we go to the get volume interface module. The get volume interface module helps the pycow to use the audio utility to take control of the audio system of the system. The audio system helps to increase or decrease the volume of our system. Set volume function helps to set the volume at 0, and it also ensures that the total volume remains within 1.0 so that any volume displayed remains within the range of 0.0 to 1.0. Hand gesture volume control system, the main part of our code. The hand gesture volume controller first initializes the soothing factor or the frame rate to be 0.2. The smooth volume. How does the smooth volume work? The smooth volume helps us to show the increase in volume. It adds the difference between the new volume and the previous volume to the previous volume. Calculate volume. This function helps us to calculate the volume and to represent it in form of a percentage. For example, if the increase in volume is 70, then it is obtained as 0.7. Representation is also required. Therefore, representation is done by draw volume bar. This representation is better defined in our project's main part, which is in the latter half of the video. The mp.hands function helps us to take the definition or the data point structure of the hand from the palm up. The image is then flipped and then it is converted into RGB or red, green and blue format. Then with the help of matplotlib display, the RGB image is displayed of our hand. Now this RGB image is then used for processing. The hand landmarks helps us to understand if the movement is going up or down, therefore controlling the volume of the system. With this, we come to the end of our code description. Now, let's move on to the video description, or how our project is going to work in real life. And this is how the project is going to work. We can increase the volume with our hands from a distance, and the green bar at the side is going to show us how the volume is increasing. At the top left corner we have the visual description of how much the volume is. It is going to be divided with 100 to give us a percentage view. Therefore, we can increase and decrease the volume from our comfort zone.
Of damaged cars like this, and so our output level is obviously damaged. On the other hand, we have thousands of cars which are still intact and the output level is intact. And so now we have what we'll call a data set, that is this inputs and their corresponding levels. And then in this deep learning model right here, we stack several neural network layers. So we have this, we have some other layer, some other layer, right up to essentially mathematical functions. If you do not have a background in mathematics, you shouldn't be worried, as in this course we shall focus on implementing all this practically. So that said, as we were saying, this we have here, or these layers, these neural network layers we have here, are essentially mathematical functions. And if we have a linear layer, then this means that we could take an input x